Okay, guys. So yeah, let's get started without any further ado. Now, in the last class, we covered up to the point of public and private IPs. I suppose, if I remember correctly, I covered the conversion from binary to decimal. We covered the range of IPs. We covered the sequence of IPs. Okay, and I'm not sure if I covered this or not, guys. Did I cover this? What are public IPs and what are private IPs? Did we
No,
talk about
sir.
all this? We didn't cover
No,
this,
sir.
right? Oh,
Yeah, yeah.
okay.
First and last
Right.
IP.
Okay, cool. Right. So let's talk about the classification of IPs in today's class then. So as mentioned, your whole IPv4 addresses from class 8, from 0000, the first IP, till the last IP, 255, 255, 255, 255, they are divided in certain categories. Firstly, this category is called classes, class A, B, C, D, and E. And again, in each class, there's two subcategories again, public and private IPs. So class A has public and private IPs, class B also has public and private, just like class C as well. But class D and class E do not have any private IPs in them. They only specifically have public IPs. Okay, so let's talk about these public and private IPs first, and then I'll cover the classes information. Okay. So when you talk about public and private IPs, guys, these are the IPs which are again used in different kinds of networks, public networks or private networks. Okay. So if you talk about the public IP, these are globally unique IP addresses which are used to again identify systems on the internet. Okay. So again, public IPs are globally unique IP addresses which are used to identify individual devices or networks on the public internet. So these are the IP addresses which are provided by the internet service providers. Okay, ISPs. So in India, you have ISPs like Airtel, Hibernate, Hathway, Idea, whatnot. Okay, so all these ISPs have a list of public IPs which they provide to the users to connect with the internet. Okay, and these IPs are routable over the internet. And if you have to check what your public IP is, you can just go to your browser and search here for what is my IP. And when you do that, you can see your exact public IP. So right now for my system, for my router at my home, this is the public IP which is provided by my internet service provider. If I want more information on this, I can click on any of these websites. And this provides me information such as the ISP as well. So Act 500 is also commonly called as Beam Telecom. So this is the ISP providing me this public IP in this location in India. Okay. On the other hand, when you talk about private IPs, these are the IPs used locally or privately in your local networks. Okay. So private IP addresses are used within private networks such as homes or offices or organizations, and they're used for local communication. So in your home, if you have 5 devices, let's say laptops or mobile phones or routers or smartwatches or whatever it be, all these devices communicate with each other in that private network using the private IPs in your local network. So they are not directly accessible over the internet. You cannot use private IPs to connect to internet directly. You definitely need a public IP for that. Okay. And these allow communication within the same local network. Okay. And if you have to check your system's private IP, if you're using a Windows operating system, the command is ipconfig. You have to enter this in your command prompt. So search for cmd and here search for ipconfig or execute the command ipconfig, and that shows you your private IP address. Right now, my private IP is 192.168.0.5. Oh, 1 second. Someone raised a hand. Yeah, Scott, you have raised your hand. You can put your question in the chat box as well, or I've just unmuted you.
This Wi-Fi is a private IP, right?
Yeah, Wi-Fi is your local private network. It is definitely a private IP. Right. So your Wi-Fi route again. If I had to explain this in a much better way, you can look at this diagram here. So this is my home network, let's say, and at my home I have multiple devices again. Okay, so I have my router, I have my laptop, my smartwatch, my smartphone, smart TV, whatnot. Each of these is a private device in my local network. So your local network is also commonly called as intranet, and each of these devices in the intranet gets a private IP. So your router gets 192.168.0.1. This is the first private IP. Laptop gets 02, smartwatch gets 03, again 04, 05, so and so, okay, randomly. Now each of these devices can communicate with each other with these addresses. Okay. But when they want to communicate with the internet, let's say when any of these devices wants to visit a website like google.com, for that they need a public IP. Okay. So your router gets a cable from outside the house. Okay, it gets an optical fiber cable or an RJ45 cable, whatever it be, which is provided by the ISP. Okay, from the ISP, that cable carries the public IP and that assigns it to the router. So now, if my phone wants to communicate with Google, first the packet travels from my phone to the router with private IPs. From the router is a device which allows communication between two different networks. Okay, so the packet now shifts from private IP interface to the public IP interface on the router. And with that public IP, it reaches the internet, the ISP, and then the desired website. So this is how packets travel, changing from public IPs to private IPs and vice versa. Is that clear, Scott? Any questions?
One doubt. This 192.168.0.1, this is given by ISP?
No. That is a private IP with that you can assign it yourself, David.
Okay.
Okay. So private IP
the
is
router. So when I do IP config, my router IP address is basically my assigned IP address.
Yeah, you can assign it yourself if you want to.
Okay.
So if you notice over here in my IP config, this is the IP which is getting given to my system, and there's something called default gateway. So default gateway is like your router. Router acts as a gateway between your private network and public network, and that is getting the first IP 0.1. Okay, my system is 0.5, the router is 0.1. Two different devices.
Okay, and the ISP and the IP address that ISP has it is a public one.
That is the public IP.
Okay, so
that is also
are
given to the router. Router has two addresses. On one side it will have a private IP, on the other interface it will have a public IP, and that is what a router's job is, to communicate between two different networks.
Okay, private to public, public to private. Okay, so the router has two IPs inside it. Okay, two informations. Okay, got it.
Yeah, it has information on two different interfaces with two different IPs, and it allows you allows that possibility of communicating from the private network to the public face network and vice versa.
Okay.
Okay, is that clear, guys? Everyone? David, Scott, Shashank, any questions? Okay, guys, assuming there are no questions, let's move to the next part. Okay, so now IP address ranges. So each class, guys, has a certain range. Okay, class A, B, C, D, and E. Again, all of them start at the first IP 0000. So class A, if you notice over here, has the first IP 0000. And class E, the last class, ends at 255, 255, 255, 255. This is the last IP. So it's very important that you remember these ranges, guys. They have been fixed by the people who invented IP addresses, and they're going to remain constant for the rest of your our lifetimes as long as IP addresses exist. Okay, an easy way to remember is just remembering these four numbers: 127, 191, 223, and 239. Let me explain why. So class A starts at 0000 and it goes up to 127, 255, 255, 255. Since it is ending at 127, next IP starts at 128. All the 255s cycle back to zeros, and 127 increments by 1. So class B starts at 128,000, goes up to 191. Since it is ending at 191, class C starts at 192. From 192, it goes up to 223. Since it is ending at 223, class D starts at 224. From 224, it goes up to 239. Since it is ending at 239, class C starts at 240. And from 240, it goes up to 255. So an easy way to remember is, again, just the right side numbers, because left side numbers start with the next range. Okay. And again, on left side, you have all zeros, and on right side, you have all 255s in the three octets. Okay. 0 to 127, 128 to 191, 192 to 223. 224 to 239, and 240 to 255. Left side you have all even numbers, right side you have all odd numbers. These are the class ranges. Now in each class, again, you have a set of public IPs and a set of private IPs, right? So from 0 to 127, guys, there's a set from 10,000 to 10,255, 255, 255. This is the private IP range in class A. Any IP within this range is a private IP. Any IP outside this range by default is a public IP, which is maintained with ISPs. Similarly, between 128 and 191, there's a small range, 172.16.00 to 172.31.255.255. This is the private IP range in class B. Any IP within this range is a private IP, and any IP outside this range is a public IP again. Similarly, in class C as well, between 192 and 223, there's a small range 192.168.00 to 192.168.255.255. This is the private IP range in class C. Any IP within this is a private IP. Any IP outside is a public IP. And in class D and class E, there are no private IPs at all. All of them are public IPs itself. So if this is still a bit unclear, let me elaborate one of the classes. So if you take the example of class A, it starts at first IP 0000, goes up to 127.255.255.255. That's the complete range of class A. Now in that complete class A range, there's a small private IP range, 10.000 to 10.255.255.255. Any IP within this is a private IP, and any IP outside this is a public IP. So from 0 up to 10, which is 9.255.255.255, and after 10, from 11 to 127, that's the other public IP range. So again, if you notice, there are two public IP ranges, one on each side of private IP. Okay, so there's a small private IP set and two subsets of public IPs in each class A, B, and C. Is that clear, guys? Any questions? David, Scott, Shashank?
Yeah, basically in every class, only very small section can be used by people. Other than that, all is ISP.
Coming in, David, I couldn't hear you properly.
Okay, so in every class, only a small range of IP addresses is being distributed to like the normal people. That is private IP. Rest is all used by ISPs.
Yes, exactly. Okay. Right. So again, let's perform a small exercise, guys. I'm going to write down some random IPs, and looking at these ranges, you have to tell me which IP belongs to which class and whether they are public or private. Okay. 1 second. Let me open up a notepad file. Yeah, so I have the same ranges mentioned here, guys, the complete class ranges, class A, B, C, D, and E, and the private IP ranges as well. Okay, now let me write down some random IPs here first. Okay. Okay, guys. So I've written down a couple IPs here. Now looking at each IP, the first one at least, tell me which class it belongs to and whether it's public or private, guys.
First one is
192.168.0.5. Yeah.
C.
Okay.
Private.
And
Class
public or
C,
private?
it's a public.
Okay, I've got one answer as private and one answer as public. Look at it again, guys, and let me know whether it's public or private.
Private.
For me, it's private.
It's a private IP. If you notice, for it to be a private IP in class C, first number should be 192. Second number should be 168. If you look at these ranges, first number is 192. Second octet is 168. And the remaining octets can be anything from 0 to 255s, right? Here it satisfies that condition. First number is 192, 168, and the rest all not considered. So this is a private IP. For it to be a private IP in class B, first number needs to be 172. Second number should be between 16 and 31. And the third and fourth can be anything from 0 to 255. And for class A, first number should be 10. That's all. Okay, 10 to 10. And all the other numbers can be anything from 0 to 255s. So I hope this is clear, Scott, why this is a private IP.
Yeah, because it started with 190. Yeah.
168. Yeah.
Yeah.
Next number 49,205, 193, 165.
Class A.
Class A, perfect. Public or private? Public,
It is
correct answer.
Public.
Yeah, it is outside the 10 range, so therefore it's a public IP. Next IP.
Next will be private. It's class A, private.
No, I guess you're looking at the wrong one. This one.
Okay. 192, 172.
Class C.
It's a public.
Public.
Class
Yeah,
C.
this is Class C. Public IP. Next one.
Class A, private.
Perfect. Next one.
150.
Class B. Class B.
Class D. Everything is this thing, right? No private IP.
This
Public.
one.
Public.
This one, David. 150, 160, 170, 180.
Public.
150. 150.
Yeah, Class B. And this is public. Next one.
230. Class D, public.
Class D. Correct answer. And public. Next one.
It is
Class B. This thing. Out of range, right? It is public.
Perfect.
No, yeah, it's public, right? Yeah.
Yeah, because if you see, this is 35 and this is 16 to 31, which is outside the range. Okay, so therefore this is a public IP. Next one.
Class C. Out of range.
Say public, yeah.
Yeah, correct. Next one.
That's class A. It's a public.
Out of range.
Perfect. Public. So what you have done here is you have looked at these ranges, guys. Okay. But again, I want you to memorize these 8 lines of data. As long as you're in your IT department, you will be using background disturbance, guys.
Yeah. Can you repeat the last time?
Yeah. Again, as I was mentioning, as long as you're in your IT department, guys, you'll be using these IP addresses a lot. So in our cybersecurity classes as well, we will be checking log files a lot. Okay. So in those logs, you see IP addresses. As soon as you look at an IP, you have to figure out whether it's a public IP or a private IP. It's very important. Okay. So that is how you utilize this information. Now, if you check it in my scenario here, if you remember, I've shown you some couple IPs in the browser and in my command prompt. Looking at this IP now, 49.204.239.71. Let me copy it here. Can you tell me whether it's public or private and which class it belongs to? 49.
Class A, right?
Yeah, it's
It's
class
A, public, yeah.
Definitely public IP. So if you notice, it is falling outside this range, 10 to 10. Okay, so therefore it's a public IP. And looking at my private IP here, 192.168.0.5. Can you tell me which class it belongs to?
It's class C, private.
Yeah, if you have actually answered this already. 192.168.0.5,
Yes.
class C and private IP.
Private.
Okay. So that is how you classify, guys, which IP belongs to which class. Okay.
One
But
doubt
now
was
the
there.
main question is, yeah, David, go ahead.
When you were showing what is my IP, you said my ISP is also called as something. What is that also?
Internet service provider, right? ISP.
Okay, you said internet service provider. Okay, you said something. It was like a big lag in the voice. So you said my ISP is Beam Techno, also known as this thing. Okay.
Fibernet.
You said ISP. Okay.
Act Fibernet. Act Fibernet. ACT.
ACD.
So this is a very common, very popular ISP in India. So my Act Fibernet, just like how we have Airtel, Idea, and all that. This is one of the companies for providing internet connection. So my ISP is Act Fibernet. So this company is also commonly called as Beam Telecom. So that's what I mean. Again, not so relevant, David, you can ignore that. Okay. So yeah, coming back to this next part is, why do we have 5 separate classes? Okay, so you might have a question. Why not just one single class with some public and private IP? So it would have made our job a lot easier. Why 5 separate classes? So the reason for that, guys, oh, Scott, your mic is unmuted. There's some background disturbance for some reason. You can mute your mic. Yeah, perfect. Thank you. So yeah, so each class, guys, has a unique number of network and host portions in it. Okay. So class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Class D and Class E have all network portions itself. There are no host portions in Class D and Class E. But what do I mean by that? Okay, what do I mean by network and host portions? To elaborate that, let's take the example of the private IPs again. Okay, so the classes, guys, A, B, C, D, and E, they are different because of the difference in the private IP ranges. Okay, there's nothing related to public IPs. No matter what public IP you take from class A, B, or C, it's the same. It's an IP belonging to the ISP. But what differs for each class is the public and private IPs. Okay, class A's private IPs, class B's private IPs, and class C's private IPs have unique properties to them. Okay, depending on these network and host portions. Okay. So if you notice over here, as we're going down the line, network portions are increasing in number. Class A has 1 network portion, class B has 2 network portions, class C has 3 network portions, class D and class E have 4 network portions in them. Now, let's talk about the relevance of this network and host. So if you remember in class C, it has 3 network portions and 1 host portion, right? So if we take the example of class C, which the first private IP in class C is 192.168.0.0. If that is the first IP, next IP is 0.1, next IP 0.2, next IP 0.3, next IP 0.4. This goes on all the way up to the value 0.255. After 0.255, what happens? This 255 cycles back to 0, and this 0 now changes to 1. So you have 10, 11, 12, 13 up to 1255. Then 20, 21, 22, 23 up to 2255. Okay, like that the cycle goes on. Now, what I mean by network and host portions is that network portions identify the network or the group, and the host portion identifies the host in that group. So this is the 192.168.0. network. In that, this is the 0th IP, this is the first IP, the second IP, the third IP, the fourth IP, the fifth IP, and the 255th IP. Like that, on a rough approximate value or on a rough value, you can connect a maximum of 255 hosts in this network. Okay, this could be my router, this could be my laptop, this could be my smartphone, my smart TV, my smartwatch, whatnot. Like that, I can connect a maximum of 255 devices. But once the 0 changes to 1, the network ID is differing. Whenever there's a change in the network ID, the network divides over there. Now, what I mean by network division is, even if you bring a device like 1.2 and connect it physically with a wire into the same router, to the same network, it will still not be able to communicate because logically it belongs to a different group. Okay, so this 1.2 can only communicate with other devices in the same network, not with anyone else. Okay, so from 00 to 0255, that's the first network consisting of 255 devices. From 10 to 1255, that's the next network consisting of 255 devices. 20 to 2255, next network consisting of 255 devices. So in each class C network, we can connect a maximum of 255 devices, not more than that, because it only has one host portion, and that host portion cycles from 1 to 255. I'm ignoring the 0th IP that is never assigned to any system. So on a rough average, we can create a maximum of 255 devices in each class C network. Is that clear? Scott, David, Shashank, any questions?
Just one question that I had, like the first network .0.0 is broadcast one, and the one is the network ID, and the last one is the broadcast ID. So it should be 254 hosts, right?
Yes, 254. Just to not make it complex, I gave a rough number.
Okay, no problem. Okay.
Yeah, this is called network ID, and this is called broadcast ID. You never use both of these IPs actually. Good point. But again, just on a rough average to make it sound a bit easier, I mentioned 254.
Got it.
Okay. Coming to class B now, guys. In class B, you have 2 network portions and 2 host portions. Okay, same logic again. First IP starts at 172.16.0.0. Next IP 0.1. Next IP 0.2. Next IP 0.3. Goes up to 0.255. After that, 10, 11, 12, 13 up to 1255. 20, 21, 22, 23 up to 2255. Like that, the cycle keeps on repeating. And somewhere down the line, you have 255.0, 255.1, 255.2, 255.3 up to 255, 255. Once both these octets are filled, 16 changes to 17. And here now the network divides. So only the first 2 portions are network portions. and the remaining last two portions are host portions. So as long as the host portions are changing, it is irrelevant. Each of these is just an individual host in the same network, the 172.16 network. But when 16 changes to 17, network divides over there. And here is where the network ends. Okay. Now after that, 17.00 to 17.255.255, that's the next network. When it changes to 18, network divides again. From 18.00 to 18.255.255, that's the next network. After 18, the network divides and starts with 19. So now in each class B network, how many devices can we connect, guys? From 00 up to 255.255. So that's a total of 255 into 255. And that gives you the number 65,535 devices. Okay. So on a rough approximate again, that is how many devices you can connect. 255 into 255 in each network. So class C can only accommodate 255 devices. But if you have a much larger organization, a much larger network, where you have 500 devices, in such a scenario, you have to go for class B addresses. Okay. Now in class A, it has one network portion and three host portions. So from 10.0.0.0 all the way up to 10.255.255.255, all of them belong to the same network. When 10 changes to 11, the network ends over there. The network divides over there. Okay. So since it has three host portions, you can connect a maximum of 255 into 255 into 255 devices in that one singular network, much larger compared to class B as well. So that is how they are different classes, guys, depending on how small or how large you want your network to be. If you want a small network, go for class C. If you want a larger network, go for class D or class A. Now, if you ask me what about class D and class E, they're all public IPs, guys, but these public IPs are not with ISP. They are special public IPs which are used for R&D, research and development, military organizations, government portals, and for broadcasting services. These organizations or these departments use DNE public IPs. Class ABC public IPs are given to the ISP, Internet Service Providers. Okay, is that clear? David, Scott, Shashank, any questions?
Yes.
Right. So yeah, that's that for today's class, guys. A quick
Can
conclusion.
you also share the videos of previous class as well as today's one?
I will surely, Shashank. I'll share last class. Scott, yeah. I'll share the recordings for today's and yesterday's class. That's what.
Yes.
Sure. So yeah, that's that, guys. Nothing further. I'm gonna exit the session now. I'll be seeing you tomorrow at the same time, where we'll cover the next concepts. Okay. Where I'll talk about some other important concepts like what is subnet mask, what is again, how do you assign a private IP, okay, and a public again, what's a DHCP server, what's a DNS server. We'll talk about all this in the next class. Quite some complex concepts. Okay. So that's it, guys. Nothing further. Since these are demo classes, I'm taking it slightly shorter. But once students get registered and we have the live sessions, we'll take longer classes as well. Okay.
So that's probably 1 hour class?
Yeah, I mean 45 minutes to 50 minutes.
45 to 50 minutes.
Yeah. Last 10 minutes usually left out for doubt sessions, if any. You can clarify your questions, or again, if you get stuck somewhere with any practical, you can ask me in those last 10 minutes in every class. Okay.
Thank you. Yeah.
Sure. Bye-bye, guys. I'll see you tomorrow.
Thank you.
Just use the same link to join.
Sure. Thank you, Shoaib.
Bye-bye.